You're not live.
We're live. Okay, great. We're live.
Okay. Hi, everyone. This is Diego from the Global Solution Teams in North America, and I'm going to host the DFP Troubleshooting Training for today. Today, we're going to talk about a number of tools that you can use during the troubleshooting stages of issues that will come your way from your publishers. Without further ado, I would go right into the presentation. So let me just share my screen and we'll be on our way. Okay. So the first tool that we're gonna cover today is called the Google Publisher Toolbar. The Google Publisher Toolbar is a Chrome extension, and it basically provides an overview as an overlay of the details about the ad requests that have been delivered on a page coming from a DFP network where you are logged in as a user. The overlay will give an overview of what the ad request is, the ad units that have been requested, and then the order, the line item, and the creative IDs, which has been delivered on the page. In order to use the extension, we would first need to install the extension itself. It's available from the Chrome extension store. And it's, of course, a free extension that will be installed on your Chrome browser. Also, in order to use the extension itself, you will need to enable the DFP account at the very least, or also AdSense, AdX, and Analytics accounts if need be. For the scope of this presentation, we're going to cover the DoubleClick for Publisher side of the overlay. Once you log into you will then be able to select a specific setting for each of the websites that you want to troubleshoot by allowing for ad overlays on these websites. And also, you will need to allow access to the publisher API, the DFP API, on the network where you want to for the publisher toolbar to be used on. So the publisher toolbar works this way. I'm going to show you live how the publisher toolbar works. Apologies, I cannot find the presentation. Sorry, we have a moment of blankness. Yes. And we're back here. Okay, so this is a test page with a number of ads delivering on the page itself, and what we can see here is that the toolbar is actually already working for the page. And the way I see it is that it's actually showing me a number of overlays on top of my ads. So again, this indicates that the publisher toolbar works. The icon of the extension is this icon here, this blue icon. And when clicking on the extension itself, we are able to see a number of information that applies to the current setup of the page. In my particular example, I'm logged in as an AdSense account user and also as a DFP account user. So at first look, we can see that when we load the extension, the number of ad slots which are present on the page, and then we can see straight away the network ID which delivered our ads, and the ad unit where the ads are coming from. Also, we can see the size of the request and what type of ads have been delivered on each ad slot, and also the creative. So the publisher toolbar basically gives us a straightforward overview of what's actually happening on the page. Now, as I've said before, the way that we enable the toolbar itself is by enabling the ad overlays for the page we're troubleshooting. And once everything is enabled, we can go back into the page and actually hover with our mouse on top of our ads to actually see information relative to the exact ad that we are looking at. Also, by clicking on the little overlay, we can get a better overview of the actual ad with additional informations that can be used in case you will need to, for example, open a consult case with our support team. This information, for example, include the actual creative and a screenshot for the creative itself, so that we can be able to identify the creative straight away. Also, within the overlay itself, we can find a number of URLs and links that will open each individual element on the DFP UI. So, for example, in this particular example, I can open the creative that was delivered, and I can see the creative directly delivered on the creative details directly on the DFP UI. So back to our presentation. So again, what the publisher toolbar does for us is that it can give us an account overview of the property that we're troubleshooting, and also allow us to gather the details of each ads that have been delivered on the page straight away without any additional tool. As I shown on the test page, the various elements that are represented within the toolbar itself, with all the informations which are, again, relative to the ads being delivered. So the toolbar is a very straightforward tool, and it's extremely easy to use. But another tool that you can use to troubleshoot ads directly on a page is through the use of the Google Publisher Console. Now, the Google Publisher Console is an on-screen debugging tool, and it's actually part of the GPT library, which is the library that it's used for implementing ad tags directly on a web page. So the GPT library will allow you to set up ad calls and then call and render these ad calls, but also provide this, which is, again, the Google Publisher Console, which can be used to identify different aspects of how the GPT is delivering tags on the page that we're troubleshooting. I'm going to show you in a second the tool itself. There are different ways to access the on-screen tool, but the quickest one is by adding question mark and then GOOGFC, which stands for Google Forced Console, to open up the console directly on the page. So I'm going to show you how this works. So this is, again, my test page. And I add the Force Console parameter. I'm going to just disable the overlays for the publisher toolbar so that we have a better view of the console itself. And this at the bottom is the actual Google console. So again, this tool is provided directly by the GPT library, and it can only work on pages where GPT has been implemented. So the information which is returned by this particular debugging tool are of two types. The first one is in regards of the ad slots themselves and the setup for the ad slots. And the second one, in the tab called Page Request, shows of how the page has been loaded and how the DFP tags have been loaded on such page. So we start from the first tab, where we again have a number of information which are relative to, again, the tag setup. So the difference between this tool and the previous tool that we saw is that the previous tool show us the information regarding the actual ads that have been delivered on the page, while this tool, the Google console, shows us the information relative to how the tagging setup is behaving on our page. So, for example, for our first slot, we can see again the network ID, we can see our ad unit, and the ad slot sizes. So these are all the sizes that have been declared for the ad slot in question. We can then see the type of containing element that are rendering our tag, and the service that is being used, which in this case is DFP. We also have a number of information relative to the amount of time that the tagging library took to fetch and then render creatives. Now, the way that this information is important to us is that it allows us to understand if our tagging setup is introducing latency within a publisher page. And generally speaking, through this particular screen, we can actually determine if certain ads are causing the page to slow down or to stop loading altogether. Also, within each individual ad slot information, we have a number of links that will send us directly onto the DFP UI to show us additional information in regards to the ad unit, where we are delivering the ad, and diagnostic tools from the DFP UI itself. In the Page Request tab, instead, we have information which are simply relative to the timeline associated to the loading of ads on the page itself. So we can see when the first ad call on the page starts requesting ads, and then we can see each individual passage which results in different ads being requested again on the same page. So again, this tool is meant to be used for the troubleshooting of the actual implementation of GPT tags on a specific page. And then going back to the ad slot page, one thing that I want to show is that we can actually open delivery diagnostic tools, and this is part of the DFP UI itself, and I'm going to show you how this works very quickly. So the diagnostic tool is basically a tool that allows us to check directly on DFP what type of ads should be delivering on a specific ad unit and for specific request sizes. So bear in mind that this is a test network, so there is not much information in terms of competing ads and so on. But generally speaking, this allows to run a simulation of ad calls for the specific tagging setup of the tag itself. So once we have all the information set, we can run the simulation, and in this case, ADEX and AdSense for my account is winning the competition. If directly sold line item would be winning the competition, we would actually see the line item details in the winning line item slot over here. So back to the presentation. Again, the Publisher Console, I reiterate, is a tool which can be used to troubleshoot and detect errors for a specific tagging setup on a specific page, and will return information regarding the ad units for that particular page, and then allow you to open part of the UI where you can see the setup for the ad unit, the delivery diagnostic, and also creative previews for the current ad calls. Again, as I also already showed, the page request tab displays basically the information relative to the timing event within the tagging setup. Also, the full list of the warnings and errors that might appear on the Google Publisher Console can be found on our Help Center. And once you'll get hold of the presentation, you will have access to the URLs to the Help Center itself. And this is simply a screenshot of the tool itself. Okay, the next tool that we're going to look at is the Chrome Developer Tool. And the Chrome Developer Tool is now a set of tools that are actually inbuilt within the Google Chrome browser. And basically allow us to troubleshoot all of the issues that are relative to either the actual structure of a web page, including the HTML, CSS, and JavaScript code which has been rendered on a page, but it also allows us to have a better overview of what are the network requests that have been fired from a specific page, and all of the subsequent requests that are generated. I'm going to show you in a second how the console works, but the console itself is divided in tabs, and each tabs represent a function of the console. And again, this tool is incredibly powerful, but also sometimes difficult to start to use. For the sake of this presentation, I'm going to show you a couple of the tabs that are part of the set of tools on the Chrome Developer Tools. But again, there is a lot of information on the Google App Center to help you start using the developer tools itself. So back to my test page, I'm gonna close the Google Console, and I'm going to load my page again. The way we open the Publisher Console is through the More Tools setting page of Chrome and into Developer Tools. This will open the console itself. And as I said, the console is divided in tabs, where each tab represents a function of the developer tool, and each tab will give us different information regarding the page that we're looking at. So the first tab is called the Elements tab, and this is basically a breakdown of all the elements that have been rendered on a page. And the way it works is that the elements are represented into the console as a hierarchical structure that we can actually drill into to uncover different elements and see how they've been rendered. So for example, when I hover on each individual element, I can see on the page itself that each element is getting highlighted, and I can actually see the content of the elements themselves. One other thing that the console can do is that we can actually modify the content of the element, and the element will automatically render with the new content that I actually set for the element itself. Other things that we can do from this particular tab is that we can use a JavaScript console where we can actually run arbitrary JavaScript code on the fly. So for example, I can send a JavaScript function to render an alert dialog, and when I execute it, we can actually see the dialog itself. Now, how does this help us with troubleshooting DFP tools? Well, DFP issues, sorry. Generally speaking, the way that we can use the tool is that we can check exactly how specific creatives are rendering on the page. So we can, for instance, look at the elements that are containing the creative and then drill into the elements themselves to look at the code that is part of the creative itself. Other things that we can do is that we can look at the actual tagging setup from the code point of view. And so, for example, in here, I have my I have the tagging setup, so the declaration of my add request on this page, where I can actually see exactly what's going on the page and what's going on with the GPT tag for the page itself. Another very important tab of the development tool is the network tab. So the network tab represents the timeline of each request being sent by the page itself. So if I refresh my page, I will start to see that a number of URLs are appearing on the timeline. So each of these URL represent a request that the page has sent externally. And so the way that we can use this part of the development tool is that we can identify our add requests and then troubleshoot the add requests by looking at the headers of the request themselves and then the actual code that has been returned by the add request. So if I filter by pub ads being the part of the domain that is returning Google Ads, I can see that I have a number of URLs that are now identifying the GPT library itself and then the actual add requests that have been sent by the tagging setup. So if I open this particular URL, we can see now the information regarding both the response and the request. And so, for example, from this particular add request and from this particular header, I can see all of the creative IDs that have been delivered on each of the ad slots and all of the line item IDs that have been on the page. Also, I can see information regarding the actual URL, which is the request URL, which is what is actually requesting ads directly from the DFP ad server. Other thing that we can look at is, for example, the response tab, which shows us the actual code that has been delivered on the page to then render the ads on the page itself. And also we have different other different tabs where we can have a preview of all of the objects that have been delivered alongside with the request. Again, this is a very powerful tool, and it actually allows us to have a deep and very granular view of what's happening when our page request adds from DFP. So, one last thing, the sources tab represents the actual sources of the script and elements that have been delivered on the page. So, for example, if I click on this first URL, which represents the actual page that I'm looking at, I can see the code that has been delivered within the page and that renders the page itself. So back to our presentation. One other functionality of the Chrome Developer Tool is that from the Network tab, which I just showed you, we can actually save what it's called an HIR file, which stands for an HTTP archive file. This file is basically it's a collection of all of the requests that have been run on the page, exactly like we saw them onto the Network tab. And the reason why we want to save these files is that we can export them and then open them in external applications where we can run an even deeper type of analysis. So, for example, an HIR file can be opened in Charles and Fiddler. Charles and Fiddlers are two HTTP proxy tools which can help us analyze the content of a page, and again, all of the requests that have been sent out by the page itself. I'm going to show you in a second then Charles as a tool and how the HIR file can be used to open the current HTTP session coming from the page into Charles itself. Now, another thing that we can use the developer tools for is to actually spoof mobile devices and also other devices. This is an actual powerful tool that can allow us to test, for example, mobile pages directly on our Chrome browser without having to open a page on an actual mobile device. There are different modes of emulation. I'm just going to show you a very basic one, which will emulate an actual mobile device. So back to my test page. I'm going to reduce the size of the tool. And the way that we invoke the device emulator is from this icon over here. So when we click on the icon, the view of our page changes, and the way that this works is that we have a number of devices that we can emulate, each device having a different screen size and orientation. And by changing the device that we are looking at, we can actually simulate the page as it would be delivered on a mobile phone or a mobile device. Again, all of the functionality of the development tool is also available in emulation mode. And additionally, we can actually use our own device strings in order to emulate different devices. The device string that we can use is a simple user agent, and therefore, if you need to, for example, emulate a specific device, so a specific mobile phone, for example, we can simply search for a user agent for that device and then add the user agent to the development tool in Chrome. So, back to the presentation. Again, these are screenshots that you can then view once you get hold of the presentation, where we actually show where the IDs and where the requests are within, for example, the Network tab for the development console. And this is an overview of how to enable and how to use the device emulation tool. Now, Charles Web Debugging Proxy. So Charles is an application. So it's not a Google application, but it's an application that we highly recommend to use when troubleshooting network issues, because it's a very simple tool, and as I said before, we can actually export the output of our Chrome development console and then import it into Charles itself, so to have a better understanding of what's happening on the page and what's been requested on the page. In regards of when to use Charles, we always recommend to use Charles when contacting the publisher support in order to provide all the relevant information about a specific case. And this is because when your publishers face issues regarding creative rendering or line item delivery and so on and so forth, it might be difficult for you and for us to actually capture the problem and actually reproduce the problem. And so we always ask to have Charles ready to be able to record a session where the issue is happening, so that you can then share the session with us, and so that we can have a better idea of what's happening with the issue itself. Now, what Charles does is that it simply records everything that is going through the network connection between the browser and the internet itself. And the way that it shows this interaction is through a similar view than the network tab in the Chrome Developer Tool, but it allows to then add additional functionality to the session recording. So, for example, we can enable SSL proxying. So basically, we would simply use Charles with its own certificate to record and analyze SSL requests coming off the web page. We can do bandwidth throttling. We can view, actually, we can rewrite requests and responses, meaning that we can set up certain rules where we actually look for specific bits of data, and then we can change this data on the go for either the request or the response. And then, as a whole, we actually get either a structured or a sequential view of the traffic on the web page. This is a screenshot of Charles, but I'm going to show you now how it actually works. Okay, so Charles can be either set as a sequence type of view, where we will see the sequence of events happening on a page by their timestamp, or a structured view, where we actually see a hierarchical view of where the requests are coming from, and within the same domain. Personally, I usually work in sequence view because it actually shows me exactly when a specific request has been sent out. So let me open another test page, and let me enable Charles so that I can record my session. So for my page, I can start a refresh of the page, and what we'll see in Charles is the actual sequence of requests that have been sent out on the page. So all of these URLs represent individual requests that have been sent out from the page. And what we can do at this point is that we can actually start to drill down and look for specific requests that might be of interest to us. So as I showed you before in the network tab, I can look for pub ads. And again, this particular tool will show me requests that have been sent out from this particular URL. And in this case, again, we have an actual ad request being sent out to DFP. And from our request tab, we can check the various elements of my request. One great thing that Charles does is that it can divide my ad request into query string parameters. And so from these query string parameters, I can see a lot of details. So for example, I can see the network ID of my request. I can see the ad units which were present in the ad request. I can see the ad slot setup, and also the dimension setup for each ad slot. Then in the response tab, I can actually see what code has been delivered by DFP for the delivery of our ads. In this particular case, we can look at the headers. And again, in the headers, as I showed you in the network tab for the Chrome Developer Tool, we can see the line item IDs, the creative IDs that have been delivered in each slot. And we can actually then, as I said, look at the actual code that is rendering our ads. Now, as I told you before, I can actually export. Specific setups from the console. So if I go back to my test page and developer console in Chrome, I can, for instance, save the content of the tab as an HAR file. Okay, and once I save it, I can go back into Charles. And I can import the session itself. And then once I import the session, I can again have access of all the information that was delivered within the network tab of the Chrome Developer Tool, and have all of the other information which are provided by Charles. So for example, again, in the request tab, I can have a look at the query string and all of the information related to the query string itself. So again, these are powerful tools, and they can be used in conjunction with each other and actually help a lot when troubleshooting all sorts of delivery issues on DFP. So I'm going to close Charles and go back to the presentation. And we are now at the last we are at the last piece of our presentation, which is the Video Suite Inspector, after which we will be opening our chat for questions that I will try to answer at the end of the presentation. Just one note about the questions, please make sure that the questions you submit are relevant to the presentation, the current presentation, as I will only answer questions that are relative to the content of this particular presentation so far. Okay, so the Video Suite Inspector is a tool which provides us, which is provided by Google and allow us to test and troubleshoot VAST requests. So VAST requests are video, are generally speaking video tags, which are delivered as XML responses, and are usually fed to video players, where the video players send out the request to the ad server, again as a VAST request. The ad server returns an XML document, where the XML document contains all of the information relative to the actual video ad being delivered, and all of the trackers that are to be sent along with the ad itself. I'm going to show you then in a second how the whole thing works, but for the moment, I can tell you that with the Video Studio Inspector, we can test VAST tags for DFP video, and we can test these requests for both HTML5 and Flash-based players. So I'm going to show you very quickly how it works. So these are a simple screenshot that show the information that we can gather from the tool, and this is a screenshot that shows us how the data is provided by the ad server. So let me open again my test page. The Video Studio Inspector can be found on the developers, on the Google developer site, and it is simply a video player where we can feed a VAST tag to in order to test our ad. For the sake of this presentation, I'm going to show you just a simple inline ad. If you don't have a VAST tag to test, you can use the sample requests, which are shown here. And for this particular example, I'm going to copy the first one. So we can simply paste our ad request in the input field and then test the ad. So the ad set itself will start to deliver, and in the event section of our page, we can actually see all of the events that have taken place in the player itself. So the way that we use this tool is actually to make sure that the video that the VAST tag itself is set up correctly and that it can be fed to a video player. So given that these particular ads require then deeper troubleshooting on the publisher website or the publisher player itself, you can use this particular tool as a starting point to make sure that the actual ad calls, the video ad calls, are working correctly, so that you can then move on to the deeper troubleshooting for the video player itself. One thing that I want to show you is that when we deliver, when we actually open an actual VAST request, this is the XML feed that we get back from the ad server, where we have a number of information such as the ad ID, which is the line item ID, and then we have the creative IDs, creative ID of the current creative being delivered. Also, in each of the nodes of the tracking events, we can see the different events which are referring to the start of the ad playing, then the first quarter, midpoint, third quarter, and then the ad being completed. Also, we have different tracking URLs which identify different events that can happen on the player itself. Each of these URL will be fired when the player receives the ad, and then the player itself sends back an event for this particular measurement. And again, back to our presentation. This is actually the last slide, and so we can start taking in questions, and we can then review the questions, and I can answer them in the next 5 minutes or so. Okay, so I'm going to take the first question, which is in regards to, so the question is, what are the things that cannot be found in Google DevTools and that can be found in CHARS? So generally speaking, both tools will show you the same type of information. CHARS has a slightly better representation of the information, and also has a slightly better way to search through the information itself. So for example, in CHARS, I can, for example, search for a specific string of code or a specific URL within the full session, and CHARS itself will actually point me to the exact location of that particular string within the session itself. So it's very powerful in terms of how we can search for elements within the session and how the data is represented. That said, the actual reason why we use CHARS, and we recommend to use CHARS, is that CHARS allows to create rewrite rules, and also can be used for a number of different scenarios where you have to spoof specific details of an add call, which would not be able through a browser. So, for example, CHARS allows to set up certain rules where, say, if an add request comes in with a specific key value or a specific value for a key, we can actually rewrite the value of the key itself, so to have a different output within the session that we're recording. One such example would be the page content URL, which is a URL which ADEX utilized to identify the page where the ADEX code is being delivered on, and then identify the context of the page itself. So sometimes, specifically in the cases where we use test pages or additional external tools which are not necessarily coming from the live web page, we can use CHARS to rewrite specific rules, such as the page URL, so that the receiving end of the request, which is the ad server, will actually think that the request is coming from the specific page that we are setting up. So this is one scenario. Another scenario, and this is something that the Chrome development tool cannot do at all, is to record session for mobile applications. So CHARS can be set as a proxy server that can be used then by a mobile phone, a mobile device, to be used while using an application. And so the traffic of a mobile device is going to be routed through CHARS. CHARS will then record the session itself and then output the data, which again, it's a very powerful tool and cannot be achieved with the Chrome Developer Console. Okay, so I'm gonna look for another question and see if we have other relevant questions. Okay, so it seems that there are no more questions that are relevant to again the troubleshooting tools that I presented today. So thank you for joining the presentation and the training, and I hope this will help you in your troubleshooting in the future. So thank you very much, and see you soon. Bye.